Hi everyone, so this next video is going to be a continuation of center pivots and of what we did last time. So if we look at management of center pivots, look at switching it on and off. So firstly, make sure that there are no obstructing equipment. So that is while the center pivot is moving, make sure that there's nothing in the field that could be damaged or that could damage the center pivot while it is finishing its movement. You change the wet dry switch to wet, and you close the mainline valve partially, and you switch the pump on. Open valve slowly until the mainline is filled with water, and then change the main switch to on position. Set percentage switch, select and press the ahead reverse switch and stop the system. To stop the system, change the stop run switch to stop. Okay, so next up we're looking at water application with center pivots. So it's very important because with center pivots you've got this span or bar that is so far above the soil that you have a lot of loss of water, and it's not always the most effective method. So with center pivots, you are trying to limit your water loss to as little as possible. So do not apply too little water, and that is because if you won't apply enough water, the water won't infiltrate deep enough, and so you'll lose a lot of water due to evaporation, and also your roots will grow too shallow. So if this is your soil surface, then if too little water falls on the surface, it'll only be in this area, it'll only stay in that area, so you'll lose a lot due to evapotranspiration. And what you would prefer is for the water to actually go down deeper into this profile. Do not irrigate when the wind speed is quicker than 20 kilometers per hour, and this is just for to make sure that your wind doesn't blow your drops away or cause the drops to evaporate too quickly. So don't apply small drops for that same reason, and apply water as close as possible to limit losses. And that just refers to if this is your soil profile, and that is the bar that is delivering water like this. Make sure this bar is not too high from your soil profile in order that you don't get any water on your soil profile. So we can actually calculate how you deliver water to your crops with a center pivot. So these are the three important formulas to know and remember for center pivots and irrigation with center pivots. So this first one, T equals, it says 2 pi r on top of 60 V, but to simplify it, we'll just say 0,1047 r, so that's the radius, divided by V, which is the travel speed of the last wheel at 100% setting. So if I can sketch this, maybe you've got a field that looks like this, and this is your center pivot that's spinning around or moving around. And so maybe I'll redraw that just a bit larger. So you've got a field like this, okay, and you have, this is your span, and then you've got, this is where the wheels are located. So that radius, it refers to, so this equation refers to the time in hours for this thing to rotate. And in other words, when we're looking at the radius in this first equation of this thing rotating, we'll take that wheel We don't take this whole area, but only that wheel. And so that is why that R value for radius is the distance of the pivot to the last drive wheel, which is there. And V is then the speed of this wheel around. The next equation is gross application, bruto toediening in Afrikaans, and that is the amount applied to the soil. So that'll be Q, which is the flow rate, so the rate at which water is leaving the center pivot, the sprinklers on the center pivot. T is the rotation time, so that's what you calculated in this first equation, divided by 10 multiplied by A, and A is the area of this whole field. And third one is the rotation time at a specific speed setting. So this time is when your center pivot is moving at 100% speed, at full speed basically, and this equation is if you're only moving at a specific speed, so 70% of full speed or 50%, etc. So these are the three equations that you need, and let's do one example of this. So the question is, determine the revolution time and gross application at a 70% speed setting for the following case. Okay, so if we can do equation number 1, so the time for this thing to rotate is that 0,1047 multiplied by the radius of this wheel. So from the center to that wheel, and that'll be a distance to the furthest wheel, so it'll be that 282.8 meters divided by the speed at which it is moving. So for that speed, just to make sure, if you are calculating it for that speed, it is that 1,64. So that's how quickly this thing is moving. But this thing says the wheel slip allowed is 3%. So 0,97, because that is 100 minus 3%. That's 97% of the actual motor speed. And your answer that you will get for this is I can quickly get my calculator. So your answer for this will be 18,6. So you write this 18,6 in terms of hours. So your answer will then be 18,6 hours. Okay, so this next one is the application, gross application, and you want to determine how much you're going to apply to this field. So Q is the flow rate. It's at 1,101 cubic meters per hour multiplied by T. So T is the time it took to do a full rotation, and that is 18,6 hours divided by 10 multiplied by the area. So that is the area of the whole field. So if you've got the field as it was sketched like this, and this is your center pivot moving Then the whole field, the area of this whole field is going to be pi times the radius of this field squared, and the radius of this field is that 308.3 meters. And so if you put that into this equation, the answer that you will get is 6.3, oh sorry, that is 0.63 millimeters. Okay, so that is the application. And then lastly, you want to know the speed set, if the speed setting is at 70%. So if we can go back here, they say that the rotation time at a specific speed setting. So the speed setting was at 100%, and you want to know when it's only moving at 70% speed, what will the time be? So that'll be that TV equals 18.6 hours divided by 0.7, and that'll be 26.6 hours. Yeah, and so from here on, it's important to do maintenance, and remember to do maintenance. So maintenance on your center pivots, if you're looking at the overhang, Afrikaans die oorhang. So if you remember from the previous video, it's just this extra part at the end. It usually gets clogged up with a lot of dirt and sand. So it's important to remember to clean that and the sprinklers. So you have to have a sieve and make sure you clean the pipes and the sprinklers. Your gearbox, try to oil your gearbox at the end of every single season. Drive your alignment, so that's the alignment of your whole structure, and then flushing. So lastly, with flushing, that is especially with your overhang that becomes full of sand and dirt. The purpose of flushing the system is to remove any excess dirt and sand that has accumulated in the pipelines. So in order to do this, you switch off your whole system, and if I can sketch this. So what you'll do is, if this is your system, this is your center tower, and then you have your center pivot like this. So switch off this whole tower, and then this whole thing, and then you'll clean the filters and the valves in this tower, so the water goes through and it is spread across this whole span throughout the whole center pivot, and it delivers water. So you firstly replace these valves and filters to make sure that the water that goes through the rest of the center pivot is clean. Then when all the dirt has accumulated right here at the end, you switch it off again and clean out this filters and valves at the end, and then switch it back on, and then both the water in this part of the center pivot and at the ends throughout the whole center pivot will be clean. And that is it for center pivots.